A long time ago, someone had a headache. They chewed on the bark of willow tree, and believe it or not, it relieved their pain. Willow bark contains the chemical salicylic acid. It's been used since before the time of ancient Egypt as a pain remedy. This is because it contains the chemical very similar to that we today call aspirin. Synthesizing aspirin is one of the 12 assessed practicals that form part of the A-level chemistry course. You'll be expected to synthesize the organic solid, purify it by a process called recrystallization, and then measure the purity of your product by chromatography and determine the melting point. Let's have a look at some current Year 13s performing their required practical.
We're doing the first step of making aspirin, which is refluxing oil of wintergreen with sodium hydroxide, and then that's going to create a sort of impure version of aspirin that has loads of other stuff in it that we then need to get rid of during the next steps. We're doing melting point determination after we've created the samples in the original experiment. So it's just testing the purity of the things we made. So we're using the melting point determining apparatus and then seeing the range at which it melts at, and if it melts within the parameters, which is 138 to 140 degrees, we know it's a pure sample of aspirin.
For this part of the experiment, we're doing recrystallization, which involves us taking our impure aspirin crystals and dissolving them in a hot solvent, and then filtering them through, cooling them down, and it should reform just the pure aspirin.
In this part of the experiment, we are using chromatography to test the purity of the sample of aspirin we made compared to drugstore aspirin and our starting reactor. We use thin layer chromatography plate, and we make 4 marks where we're going to put each of our samples, and then we pop it into a solvent, and the solvent separates the samples, so then we can compare it using either UV light or iodine to compare the samples to the pure aspirin.
We have these glass capillary tubes. They're hollow, and we heat them over the roaring flame, like so, until the glass in the middle starts to get liquidy, and then we pull it apart. And it forms this big strand, and then what we can do, we break the end off, and it forms this little thing here that can be used to drop small amounts of liquids onto chromatography paper.
We study OCR A level chemistry, that is A route rather than B route. There are 6 modules spread over 2 years. You study modules 1 to 4 in year 1 and module 1 and 5 and 6 in year 2. There's some practical skills. We do a lot of practical classes, and the assessed practicals contribute to the practical endorsement at the end. There are 3 written papers at the end of year 13, 6 hours in total, and 15% of those questions will be on your practical activities and a minimum of 20% on mathematical skills for chemistry. So what attributes will be required from students studying A-level chemistry? You'll need a minimum of grade 7 at GCSE science or chemistry. You'll have a good level of math skills. You'll enjoy problem solving, have resilience and perseverance, and an inquiring mind. What can you expect from your chemistry department at Harington? Friendly and caring, approachable staff, personalised intervention programmes, fully equipped laboratories, an extensive range of chemicals, staff who are experienced at teaching A-level chemistry, regular assessments so that you can track your progress and identify areas requiring further work and support, and opportunities to extend your knowledge beyond the specification with the Year 12 Chemistry Challenge and the Year 13 Chemistry Olympiad. Both are run by the Royal Society of Chemistry. So successful students from 2019, a student went to Cambridge University to read natural sciences, 1 went on to read medicine, 2 students secured places to study veterinary medicine, and several others went on to study chemical engineering or related subjects. I'm looking forward to seeing some of you here at Harington next year. Thank you.